All right, today we're going to start 10.5, other angle relationships in circles. We'll start with the first theorem. These are all going to be dealing with chords and secants and tangents that create angles and arcs. So this first one deals with having a tangent here. So if a tangent and a chord intersect at the same point on a circle, so obviously they're going to intersect there at that point of tangency, then the measure of each angle formed is half the measure of its intercepted arc. So this is pretty much the same thing, or similar concept to our inscribed angle theorem. So we say that angle 1 right here is going to be half of arc A to B. Again, like that inscribed angle theorem. These aren't quite inscribed angles, but it's the same idea. Whereas angle 2 is going to be half of angle A to C to B. So in other words, if arc AB were, say, 100, that would make angle 1 50 degrees. If you need to copy this down, feel free to pause it. So if we look at these examples, here we got a tangent. Got angles 1 and 2. This arc is 162. So let's just start with the measure of angle 2. To get that, we got to divide the 162 by 2. So that would be 81 degrees. Then we got angle 1. Well, there's a couple ways you could find it. The hard way would be to take 360 minus 162, get this arc, and then cut it in half. But you should notice that this here is just a linear pair. So you simply can do 180 minus 81, and then angle 1 would get you 99 degrees. Down here, got some variables to deal with. So we know that angle 4 is going to be half of x minus 7. We know angle 3 is going to be half of 4x plus 2. Problem is we don't know what x is. Good thing is we can add up these two arcs, and they're going to add up to 360. So we got 360 equals x minus 7 plus 4x plus 2. And then we can simply solve that. See, that would be 5x. And we get minus 5. Add 5 to get 365. And then divide by 5, and that would be 73. So that's x. Now we got to find the measure of our two angles. So measure of angle 3. Well, if we plug in 70, well, actually, let's do measure of angle 4 first. That's going to be easier. Not that you can't do 3 first. But it's a lot easier to plug in 73 here. 73 minus 7 is going to get us 66. Now we need to take half of 66. So 33 degrees. And then angle 3, again, we can do that linear pair. So take 180 minus 33, and we would get 147. So again, when you have a tangent and a chord, these two angles here, you take half the intercepted arc, just like inscribed angle theorem. Next one, we have inside angle theorem. This happens when you got two chords intersecting. Remember, a chord has endpoints on the circle. So when these two chords intersect, they obviously create four angles. But for this example, we're just going to look at angle 1 and angle 2. It says if two chords intersect inside a circle, then the measure of each angle, so here we're talking again 1 and 2, is half the sum of the intercepted arcs. And we know angle 1 and 2 are going to be congruent because, well, they're vertical angles. So to find the measure of one of those angles, you take your arc AB and arc CD, the two arcs that correspond with those angles. You're going to add them and divide by 2. So you're kind of averaging out these two arcs. So here's how that looks like. So x is going to equal 83 plus 87 divided by 2. So add those up, you're going to get 170, and cut that in half, you're going to get 85. So that's a pretty simple example. Down here it gets a little trickier because now our variable is over here. See that this angle corresponds with these two arcs and not those two. So the first thing we're going to want to do is figure out the angle next to 62. So subtracting from 180, we get 118. If we follow the same pattern up here, our angle is 118. So we do 118 equals, and this would be 130 plus y divided by 2. To get rid of this 2, we multiply both sides by 2. So this would be 236 equals 130 plus y. And then obviously we subtract, and we get 106 for y. So remember, the inside angle is going to be half of the two intercepted arcs, okay, of the sum of those two. But make sure you're using the actual angle that intercepts those. Because again, 62 does not correspond with y and 130. It would correspond with these two arcs there and there. And one more. It's one theorem, but there's kind of three different cases. Because as you can see here, we got a tangent and a secant. Here we got two tangents. Here we got two secants. These are called outside angles because they're outside the circle. So again, we have our three cases. If a tangent and a secant, two tangents, or two secants intersect outside the circle. So again, that represents these three situations. Then the measure of this outside angle is going to be 1/2 the difference of the intercepted arcs. So in other words, we're going to take half of arc BC minus arc AC. Because notice BC is intercepted, that's the big one. Okay, so that comes first, and then AC is intercepted. Here, angle 2 is half of arc ABC minus arc AC. And then here, angle 3 is half of arc BD minus arc AC. So it's 1/2, then the far arc minus the closer one. In all three of these cases, you do the same thing. So here we have an example. Our outside angle is 60 degrees. We're supposed to find arc AB. We know that CDB, see how close I can follow this, pretty close. That arc is going to be 170. And we're trying to find AB right here. So if we set that up, so you always start with the angle. So 60 is going to equal 1/2 the far arc, which is 170. And then plus, or sorry, I shouldn't say plus, minus, minus the close arc, so AB, which we don't know. So since we don't know it, that's our variable, that's our x. Now to get rid of the half, we multiply both sides by 2. So 120 equals 170 minus x. We subtract -50 equals -x. So then we can say x equals 50. And you go ahead and check it. 170 minus 50 is 120, divided by 2 is 60. Here we got all sorts of fun variables. So our angle is x, so we're going to say x equals, then we got our 1/2. And then we got to subtract BCA minus AB. So we're going to have a bunch of parentheses here. 5x minus 40 in parentheses minus 2x plus 15. You'll see why we need the parentheses here in a second. Now, this is not a FOIL problem. We have a minus here. It's not multiplication. The only time you FOIL is when you have multiplication. So again, subtract. So let's simplify our parentheses here. So we got 1/2. And then we're going to have, we got 5x. It's not this negative. You do the sign that's in front. So positive 5x minus 2x is 3x. Negative 40 minus 15 is negative 55. Then we got to multiply both sides. Not by a chew, sorry, but by 2. So 2x is going to equal 3x minus 55. Subtract our 3x. And then we can divide or multiply by -1, and we get 55 5. And there it is. So when you're working on these problems and you forget what to do, just go back to your theorem and follow the example here. Plug in the things you know. All right, a little bit of a challenge problem. It says the circles are concentric, and that means they have the same center, so you can imagine they both have a center here. You're supposed to solve for x. That might be a little confusing because if you're looking for an outside angle, well, we're not given any. There is one here. This would be an outside angle of the smaller circle. But the key to this is what you're first going to want to do is figure out this outside angle here. If you look at the big circle, this would be an inscribed angle for the 116. So we can cut that in half. And cutting 116 in half, we're going to get 58 degrees. So now we have an outside angle. We have an intercepted arc here and an arc here, which is our x. So now we're just kind of looking at this smaller circle. So remember the outside angle, which is 58, is going to equal 1/2 the far one. Now we're only looking at the little circle. So we're not dealing with the 116 now. Okay? We're dealing with this x is the intercepted arc there of that small circle. So we have x and then minus the other intercepted arc, which is 30. Multiply both by 2, so we get 116 equals x minus 30. You might notice a pattern here. What ends up happening is the x ends up being, if you plug it into an equation, you get 116 equals this one minus this one. And that will kind of be a pattern for all those types of problems. So again, we add 30 and we get 130, not 136. That's some bad math. We're going to get 140. And now I can't write. 146 for our answer there. Feel free to go back in this video when you're working on problems and you're like, hey, I see a problem like this. Let's maybe go back to this page and look what we did if you don't remember. Okay, same thing here when you're working on these. If you don't remember, when you're working on your assignment, come back to this page and use it as a reference. All right, so here's your assignment. I will be back on Monday to go over any questions on this. So get as much done as you can, so that way on Monday you know which ones you can't figure out and you need help with. Don't forget the extra 1 through 6 on page 686. All right, hope you have a good weekend and go Gophers.